Right. Right, so we are on unit 10.2, and what we're going to be working on today are permutations and combinations. Okay, permutations and combinations. Okay, a couple different kind of definitions that you need to know here. First one is that a permutation, a permutation is where arrangement, or is an arrangement, is an arrangement where order matters. Okay, so an arrangement where order matters. Okay, there are 5. So a couple examples of permutations. Okay, remember where order matters. In a permutation, or an example of a permutation would be something like a race. Okay, races, where someone would finish first, second, and third. Okay, it does matter to you if you're in a race what order you finished. Correct spelling. Spelling is another one that we consider a permutation. And another example of a permutation would be phone numbers. Okay, phone numbers is another one. Yes.
Like a license plate would be
a license. It depends. I'll show you later. If you're going for, like, if you're just going to make a license plate, technically order wouldn't matter. But if you're trying to make a specific license plate, then your order would matter.
California one where it's number, letter.
Right. Yeah, that is probably order does not matter because it's just any number, any letter, that kind of stuff. Okay, let's try another one. And then the other thing that we're going to go over today is something called a combination.
What does that say in the first bullet point?
Races. Okay, a combination is an arrangement where order does not matter. Combination is an arrangement where order does not matter. Okay. And an example of an arrangement where order does not matter is if you're making a committee. A committee. Okay, so permutation is an arrangement where order does matter. A combination is an arrangement where order does not matter. You will definitely need to know the difference between the two. Okay, you have to know the difference between the two. The way that I remember the difference is I think of a combination pizza. Okay, combination pizza, say I order a combination pizza and it has mushrooms and olives and green peppers on it. It doesn't matter to me what order they put those ingredients on, as long as they all get on there. So I don't care what order you put things in. Like if you put the onions first or if you put the olives first, as long as everything gets on my pizza, that's all I care about. So that's how I remember the difference. Okay, the combination is something where order does not matter. And a permutation is something where order does matter. Okay, the formula for a permutation is NPR, and that is equal to n factorial divided by n minus r factorial. Okay, NPR, so n factorial divided by the difference between n minus r factorial. A combination, its formula is NCR, and it is equal to n factorial over r factorial multiplied by the difference, n minus r factorial. Okay, so we're going to be dealing with 2 different formulas today and for this whole unit. By the way, your unit test on this is a shorter unit. We will finish this unit this week, and you will take a test next week on block day. So it's going to be pretty fast this time. Okay, so for example number 1. Okay, for example number 1. If I tell you if Abe, Bill, and Chad, run a race. Abe, Bill, and Chad run a race. How many different ways are there to award first and second? If Abe, Bill, and Chad run a race, how many different ways are there to award first and second place? So let's write down what are the different ways that they could finish. Okay, it could be that Abe finishes first and then Bill. How else could they finish? Bill and then Abe, okay? How else could they finish? Chad and Abe. Abe and Chad. Any other ways? Chad then Bill. Bill then Chad. Any other ways that they could finish? No? Okay, so there's 6 different ways that they could finish. Okay, do we all agree that there's 6 different ways they could finish? What is this? Is this a permutation or a combination? This is a what? Permutation. Okay, this is a permutation. It is important which way they finish. Okay, order is important. So, if you didn't want to write down every single way they could finish, you could also use the permutation formula. Okay, so this would be the number of things you have to choose from, so the number of people that started, 3, P, and how many places you're finishing. So 3P2. Okay, again, if you plug this into the formula, this would be 3 factorial divided by 3 minus 2 factorial. So that would break down to 3 factorial over 3 minus 2 is 1 factorial. Remember, factorial just says that we take every whole number or every integer below that and multiply them together. So if you multiply everything together, what do you get? 6. Okay? So instead of writing every single way out, you could just use the permutation formula. Okay? Also, this could be done on your calculator. Okay? If you have a calculator that looks like mine, that's great, and I can show you how to use it. If you don't have one that looks like this, I can still probably show you how to use it, okay? The way you do this is you put in 3. All of my probability and statistics buttons are under PRB. You can see under there is NPR, NCR, and factorial. We're doing permutation, so NPR 3, NPR 2, and that would give you 6. Okay, so you can use a calculator on here if you have one. Okay? Let's try another one for number 2. Number 2. From Abe, Bill, and Chad. From Abe, Bill, and Chad. Pick a cleanup committee. Pick a cleanup committee of 2 members.
Oh, I know what it is. Like a combination.
How many are possible? How many different cleanup committees are possible? So if we look at our previous example, we know that it could be Abe and Bill, Abe and Chad, Bill and Abe, Bill and Chad, Chad and Abe, or Chad and Bill. Is this still true? Why does this not work for this type of problem? Because if you're picking a committee, does it matter if I pick Abe and Bill or Bill and Abe? No, the order is not important. These are exactly the same, so we don't need both. These are exactly the same, so we don't need both. These are the same, so we don't need both. Okay? This only has 3 different possibilities. Okay, so this is a what? Combination or permutation?
Combination.
This is a combination. Sorry. This is a combination.
So, I'm lost.
So we know that this one, it doesn't matter what order they pick people, because Abe and Bill is the same thing as Bill and Abe. Okay, whereas in a race, it matters which one's first, which one's second.
So there's only 3 options.
So there's only 3 options, right? Abe and Bill, Abe and Chad, or Bill and Chad. Because these are the same thing, so we don't count them twice.
Oh, okay.
Okay? This is a combination. So if you did 3C2, that would equal 3 factorial over the right one, which is 2 factorial, multiplied by the difference between the two. Okay, so that's going to give us 3 factorial is 3 times 2 times 1 over 2 factorial is just 2 and 1 multiplied by 3 minus 2 is just another 1.
What does N and R stand for?
Those are just the variables that you're given. So your answer here is 3. The N stands for how many things you have to choose from, and the R is how many you're choosing. Okay, so that would just give you 3. Okay, so we're going to be using, you're going to see different scenarios today, and we have to figure out, is this a combination or permutation? Okay, part of your homework is only going to be determining, is it a combination or permutation? Okay, you're not even going to have to do anything. Okay, let's try a couple more. For number 3, okay, I would like to know how many 2-letter combinations can be made from A, using A, B, C, or D. How many 2-letter combinations can be made using only the letters A, B, C, and D? Do you think this is a combination or a permutation?
Combination.
Combination, exactly. It says the word in there. Okay, so to set this up, you would write, how many choices do we have to start with? 4. C, and how many are we picking? 2. So this would simplify to be 4 factorial over 2 factorial multiplied by what? 4 minus 2, which is another 2 factorial. If you work this out, that's going to be 4 times 3 times 2 times 1 over 2 times 1 and another 2 times 1. And then the 2 and 1 will cancel with one of them. 2 and 1 cancels with another one of these. So your answer should be just what?
6.
6.
You don't want to put them together.
Well, we do multiply them together, but you want to reduce first. It's easier to reduce first.
No, but like when you subtracted them.
Oh, you don't multiply these together
Yeah.
first. Is that what you're saying? Yeah, no.
Alright.
Because it's easiest to reduce first. Otherwise, you have big numbers divided by another big number. So it's easiest if we can reduce and you don't have to multiply quite as much. Okay, just 2 more, guys. For number 4, I want you to find 15C7. 15C7. Just practicing how to set up a combination. 15C7.
Holy crap.
So if we were going to write this out, this is 15 factorial divided by what?
7.
7 factorial times by 8 factorial. Okay, so you have to understand these formulas. You have to use them. Okay, you have to use them correctly. So this one, if you simplified it, if we wrote this out, this would be 15 times 14, 13, 12, times 11, times 10, times 9, times 8 and everything below it. I'm going to write now 8 and everything below it like that because I know that I have this 8 and everything below it to cancel it out. Okay, so that's why I'm not writing them all out. But for the 7 factorial, you do need to write those out. 7, 6, 5, 4, 3, 2, and 1. Now, what's going to be able to cancel here? The 8 and below reduces each other away. What else?
3 and the 9.
Well, we want to try to cancel out the biggest things possible.
3.
Okay, so like 2 and 7 cancel out all of 14. What else could you put together to cancel things?
3 and 5.
3 and 5 cancel out the 15. What else can cancel?
6 and 12.
The 6 and 12. Okay, so it's going to reduce. That'll give you a 2. And then the 2 cancels out with the 4. And this 2 on the bottom will reduce with the 10. So now, if you clean all of that up, you're really multiplying 13 times 11 times 5 times 9. Okay, again, you would probably want to use a calculator for this, and that would give you 6435.
What'd you do with that for? The one on the bottom.
We reduced it. get reduced away.
13 and
So 13 times 11 times 5 times 9.
Just get a calculator.
Okay, last one for number 15. Or excuse me, number 5. Sorry. Number 5. I want to know in how many ways can a student select courses or select classes, excuse me, from 7 electives and 5 core classes if 3 electives and 3 core must be taken. So, for instance, if you're going to college, okay, your schedule isn't made for you. Okay, you have to pick which classes you'd like to take. Okay, so say your first semester of college, you say, okay, I'm going to take 3 electives and 3 of my core classes. Okay, how many different options can I have? Because it's not just like, you have to take this math or you have to take this history. Okay, there's a lot of different options that you have. So if you have 7 electives to choose from and 5 core classes to choose from, and you want to take 3 of each, how many different possible schedules could you take? Schedules meaning, like, how many different combinations of classes could you take?
30.
Do you think think 35?
Do you just multiply the 7?
No, we can't just multiply the 7 and the 5. Are these what? Is this a combination or a permutation?
Permutation.
Combination.
Combination. Right. Does it matter if you choose to take piano or if you choose to take art? Does it matter which one you pick first? No, it's still going to be in your schedule. So this is a combination. Okay, so you're going to take your core options multiplied by your elective options. So we already said that this was a combination. So how many core classes do you have to choose from? 5. Okay, so this is how many you have to choose from. And how many are you actually going to pick? 3. So you have 5 to choose from. You pick 3. Multiplied by, how many elective options do you have to choose from? 7 electives. And how many are you going to take? 3. So now we have to actually do this multiplication. Okay, so 5c3 becomes 5 factorial over 3 factorial, 2 factorial, multiplied by 7 factorial over 3 factorial, 4 factorial. I want you to try to work that out, and we'll see if we can get the same answer. Okay, try working that out.
But you can't just add them together in 5?
For what to be 5?
3 factorial and 2 factorial.
No, these do not add together, because that's really 3 times 2 times 1 times 2 times 1. So no, there's no adding and multiplying there. No.
You can't do anything with factorial like that?
Nope. So hopefully after you work this all out, you should have gotten 350. So there's 350 different combinations of classes you could take. Now to further complicate that, when you go to college, you can have, there's might be 10 different times that one class is offered. So that's a little complicated. So when people say, oh, I can't get any of my classes, not entirely true. Maybe you just need to think of a different schedule to get your classes, okay? I know that It's difficult for some people, but you can get your classes. Okay, homework for this is going to be worksheet 2 in your green book. Okay, you're doing numbers 1 through 23. Worksheet 2, numbers 1 through 23.